Have you ever tried to import a set of points from an external CSV file like this into a GIS software like QGIS or ArcGIS Pro, but ended up not being able to see them displayed accurately on the map canvas where they're supposed to appear? Then this tutorial might be of interest to you. In this tutorial, we're going to try to import some point datasets into ArcGIS Pro, and we're going to deliberately make a couple of mistakes here and there, and of course correct them later on so that you can see whether you're doing the same mistakes or not, which potentially may be the reason that's preventing you from seeing those points on your map canvas at those precise geographic locations. So we'll do this following an example that you might come across at some point in your GIS learning journey. And I'll be providing you with the datasets that I'll be using for this tutorial to you as well, which you can download from the link given in the description below. So you can just follow along and make sure that you understand the steps correctly. So the very first dataset that I'm going to be using for this tutorial will look like this. And as you can see, it's just a bunch of XY coordinates. And the only information that's stated along with these coordinates is that it says that it's station coordinates around Lisbon, Portugal. So you can sort of imagine if you manage to grab some information from some form of an external source, and if you were given this sort of a point coordinate data set, the least that they could do is letting you know at least the approximate geographical location where these points are supposed to be at least to give the rough geographical location where these points belong. And you can see a peculiar pattern by looking at these numbers. So you can see it's generally a whole number followed by a bunch of decimals. And if you've been working with the GIS data for quite some time, you probably might be able to immediately notice what sort of a geographic coordinate system these coordinates potentially might belong to. And more often than not, if your coordinates happen to look like this, they're generally in decimal degrees, and it would generally belong to a coordinate reference system called WGS 1984 Geographic Coordinate Reference System. And since it's given that these points are supposed to be at least roughly around Lisbon, Portugal, what you actually could do is you could probably open up your GIS software and change the coordinate reference system of your data frame to match the same coordinate reference system that your data happens to be in, which is WGS 1984 Coordinate Reference System, Geographic Coordinate Reference System. So to do that, what you can do is you can right click over here on Map, and you can head over to Properties. And from here, there's one tab called Coordinate Systems. And from here, you can see that by default, it's not in WGS 1984 Geographic Coordinate Reference System. So what you can do is you can just expand this one right over here, and you can go to World. And then from here, you can select WGS 1984 Geographic Coordinate Reference System. And if you check the details of that, you would probably see this ID. And this is a very unique ID, 4326. Usually in the GIS industry, when we refer to this very standard particular coordinate reference system, you'll also find people referring to that using this EPSG code 4326. It's a very well-known EPSG code just because of the fact that this is a very commonly used coordinate reference system. So you can go ahead and select that and click Apply. And as the next step, what you can do is you can roughly zoom into, well, Lisbon, just because we have some sort of a clue given in our dataset that it's supposed to be around Lisbon, Portugal. And next, what you can do is just as a preliminary check, you can see that when you move your mouse pointer around, usually in every GIS software, you will see some sort of a dynamic change in the coordinates, indicating the exact coordinates of the position of your mouse pointer down below at the bottom. So you can see that as I'm moving my mouse pointer around, right over here, you can see the numbers are actually rapidly changing, right? So that too is giving us some form of an indication about the numerical coordinates of the geographical locations around this point. And if you go ahead and open this up, you can see that we can actually obtain the values in a number of different formats. If you decide to go with degrees, minutes, and seconds, you can just flip this to degrees, minutes, and second. And now you can see that you start seeing the numbers in a bit of a different manner. But as I told you guys, referring back to the original set of coordinates that we had in hand, it has the characteristic of having a couple of numbers before the decimal point and a bunch of decimal values as well. And as I told you, with this sort of a characteristic, at least we can come to the temporary conclusion that this is in decimal degrees. So I'm going to flip this back to decimal degrees. And now if I move my mouse pointer right around Lisbon, you can kind of start seeing that we actually, if you start looking at the numbers and at the bottom and start comparing them to what you're seeing on the table, you will start to notice some peculiar patterns. For example, let's say if I just leave my mouse pointer right around here, you can see that the coordinate that you're seeing at the bottom of the screen is 8.743 something something, and the Y value is 39.002 something something. And if you look at the table, you kind of start seeing a similar pattern. The majority of the numbers are either 8 or 9, then decimal point, and then followed by that a bunch of different decimals. And the Y value is 38 or 39 and a bunch of different decimal values as well. And let's just move your mouse pointer drastically away from Lisbon, and now you can see that the values actually do change quite rapidly. And now they're no longer reflective of the values that you actually see on the table. So that gives us the first preliminary indication that we're actually on the right track in terms of getting these coordinates displayed as points on our map. Now, before we go ahead and do that, let's just change our coordinate reference system to something else. So since you're talking about Portugal generally use quite a number of coordinate reference systems. And what I'm going to do is I'm going to flip this to another common projected coordinate reference system that's being used by Portugal, which is this ETRS89 Portugal TM06, and the corresponding EPSG code for that is 3763. So let's go ahead and change the coordinate reference system of our data frame into that. And one of the easiest ways of searching for coordinate reference system is by using the EPSG code. So I'm just going to type that 3763, and after that, if I just hit enter, you can see that it basically gave me the ETRS 1989 Portugal TM06 coordinate reference system. So after that, we can go ahead and click apply and click OK. And now we have transformed our data frame into a projected coordinate reference system as opposed to the geographic coordinate reference system that we had previously. And with that, you will actually get some extra functionalities. For example, if you just go ahead and click over here, now you will see that there's actually one option to change the map display units to meters, which was not really possible when we were using geographic coordinate reference systems, because it doesn't really make sense to use meters as the unit of measurement when we are working in a geographic coordinate reference system. But that's being enabled now since we switched over to a projected coordinate reference system. So I'm just going to click over here, and now you can see that the numbers that you're seeing on the screen are actually completely different. And as I told you before at the beginning of this tutorial, if you would like to bring over the points, or if you like to bring over the coordinates in the form of points into your workspace, it's always essential to make sure that you're using the correct coordinate reference system. So what I'm going to do is now I'm just going to go ahead and open up that file, which is this one right over here. And I'm just going to clean this up first of all by getting rid of these first two rows. And now you can see that we just have a very clean bunch of coordinates. We have the heading XY, and followed by that, we have the actual coordinate values. And right now this is in Excel format. So I'm just going to go ahead and save this as a CSV file again. So let's just go ahead to File, Save As, and from here we're going to go ahead and select CSV, delimited file, and let's just name this as coordinates R1, and let's just go ahead and save this as a CSV file. All right, now what we can do is we can go ahead and close this. Then we can head over to View, go to Catalog pane, And I'm just going to right click on these folders and make a folder connection to the location where I've saved those, which is this file right over here, and click OK. And now if you expand this and expand the corresponding folder, you will start seeing that coordinate file right around here. So that's coordinate R1. What I'm going to do is I'm just going to drag this and drop it over here into my workspace. So you can see that it got added as a standalone table. And you can just quickly inspect if you wish to do so by right clicking over here. And if you open this up, you will now see the exported XY set of coordinates. And if you have the coordinates in a table like this, the way to add them as points into your map canvas is by right clicking over here, and you can go to this option right around here, create points from table, and you can select XY table to point. And as you can see over here, we have to make a couple of selections. The input table is already selected. The output feature class, well, I'm just going to leave the name, the default name as it is for the time being. And you can see by default the corresponding X field and the Y field has been selected correctly. And when it comes to the coordinate system, this is quite important now. If you didn't make the right coordinate system selection, it's actually not going to display the points properly. Let's say, for example, we happen to just change the coordinate reference system of our data frame into a projected coordinate reference system, which is ETRS89 Portugal TM6. And if you thought that, yeah, just because my data frame is in that particular coordinate reference system, I need to change this to match that as well. So what you would normally do is you would just go ahead and open up the list of coordinate reference systems and potentially maybe search for 3763, which was the ETRS89 Portugal TM06. And if you select that, and after that if you go ahead and click OK, you can see that the tool is actually running, and you can start seeing actually a bunch of different points. But the question is, did these points get placed in the correct geographical location? What we can do is we can zoom out and we can see where exactly those points happen to be. Now you can see that I'm zooming out quite a lot, but I still can't really see where exactly this location is. And as you can see, Lisbon is supposed to be right over here, but the points got placed way further away from Lisbon. And in most cases, if you use the wrong coordinate system, the points might even get placed in a completely different geographical zone as well, just because of the disparity between the numbers of the coordinate reference system that they're supposed to be in and the one you used during the importing process. So I think by now the issue might be clear for you guys. We managed to import the points, but not to the right location, just because during the importing process, we completely neglected what sort of a coordinates reference system these points are supposed to inherit, which is supposed to be WGS 1984 Geographic Coordinate Reference System. So what we're going to do is we are going to remove this. And now what we can do is we can right click and head over to create points from table and select XY table to point. And this time, well, we're going to have to select probably another file name. So I'm just going to slightly change the file name, and this time I'm going to make sure that I select the correct coordinate reference system. And by correct, I mean the coordinate reference system that the original points or the original coordinates are supposed to have. And just by looking at the points, we came to the conclusion that they're supposed to be in WGS 1984 Geographic Coordinate Reference System. And you can see that we no longer have that over here. So what we have to do is we have to go to select coordinate system, and from here, well, the easiest way is to put in 4326. This is the EPSG code of WGS 1984 Geographic Coordinate Reference System. When you hit enter, you will see this WGS 1984 selected, and click OK. And after that, you can just go ahead and click OK. And now you can see that the points actually got placed around Lisbon, and it looks much more realistic when it comes to its appearance. And this is actually how it's supposed to be. So if you just well, increase the transparency of the background layers just a little bit so you'd be able to see the points clearly. I could maybe go ahead and increase the size of the points as well, and maybe change the color as well. Well, the size is controlled by this, and this is the outline width. Yeah. So as you can see, the points actually got displayed correctly. And the issue that we were having previously is that we were using the wrong coordinate reference system to import the points. All right, so since all of that is sorted, let's jump into the second example, and we're going to have a dataset that's slightly different from the one that we had previously. And with that dataset, I'm going to discuss a couple more challenges that you potentially might come across when engaging in this sort of an exercise where you're trying to transform a bunch of coordinate information into points like this. So let's just clear our workspace by removing this layer first. And the second example dataset that I'm going to present to you guys is going to look something like this. And as you can see, it's just another XY coordinates dataset. It's nothing fancy. And as you can see, if you carefully start looking at the numbers, you will realize that it looks absolutely nothing like the numbers that we saw in the previous case. Most of the numbers, they look like long integers, and some of them do carry a decimal point or two, as you can see over here. So you can see in terms of the characteristics, it looks completely different. One thing that you can say for sure at this point of time is that you can't really assume that these coordinates belong to the previously assumed coordinate reference system, which happened to be geographic coordinate reference systems. So since that's out of the way, your first real challenge is going to be figuring out what sort of a coordinate reference system these numbers belong to. Now again, I'm trying to keep this as real as possible. So for example, let's say if you got this information from some form of an agency or maybe from a friend of yours, the first thing that you could do is maybe to reach out to them and get a clarification on, hey, what sort of a coordinate reference system are these numbers in? And if they can assert that these numbers actually belong to this particular coordinate reference system, then that's a good starting point. But in this case, if you scroll down just a little bit, you can see that there is a slight hint given that these are UTM coordinates. So I think that's actually going to be our savior for this example, because UTM is another type of a projected coordinate reference system where the entire globe is basically projected onto a flat surface like this, and the northern and the southern hemisphere has been divided into two different parts, each country, or sometimes if the geographic area of the country is too big, it might actually fall into a number of different UTM zones. So the very first task that's in hand for us is to find out what's the UTM zone corresponding to Portugal, and specifically Lisbon again, since we're talking about that geographical region. And there are actually a couple of ways of doing that. If you use a UTM zone map like this, you probably will be able to see Lisbon belongs to UTM zone 29. And since it's in the northern hemisphere, the UTM zone that corresponds to Lisbon in Portugal is UTM zone 29 north. So that's one way of finding that out. Another way of finding that out if you're using ArcGIS Pro is by simply heading over to this button right over here, and you can select UTM from here. And when you move your mouse pointer over to Lisbon, you will see the UTM code right down there. That's 29. And since we are in the northern hemisphere, the corresponding UTM zone is 29 north. So what I'm going to do is similar to what we did previously. I'm just going to go ahead and open up the catalog pane, and I'm going to import the station coordinates given in UTM into my workspace as well, simply by dragging it and dropping it over here. And we can have a quick look by opening that up. And you can see the numbers that we saw previously. And basically what you're going to do is you're just going to follow the same process that we did previously. Right click and go to create points from table and XY table to point. And as you can see, everything seems to be on point. And when it comes to the coordinate system, you can see that right now by default, for some reason, it assumes that it's in GCS WGS 1984 Geographic Coordinate Reference System, which is absolutely not the case. If you were to go ahead with this, it's actually going to place your points in a completely different geographical zone. So what we need to do is we need to now navigate into the correct coordinate reference system. So since we're actually after projected coordinate reference systems, what we can do is we can shrink all of these other stuff up and expand projected coordinate systems, and from here we can select UTM and WGS 1984 Northern Hemisphere, and it's supposed to be 29 north. That's what we said previously. Click OK and then click OK to run the tool, and now you can see that the points again got placed precisely around Lisbon, just like what we expect, because we managed to select the correct coordinate reference system. So that's the reason why it actually appeared in this right location. So if you just go ahead and open the attribute table, you'll be able to see the UTM coordinate of each of these different locations. And from here onwards, it just becomes a matter of basically exporting this into a separate shapefile of your choice and start performing all sorts of geospatial operations on that. And just before we wrap this up, last time when we were setting the coordinate reference system of our data frame, what we did was we selected, well, if you go to properties and select the coordinate systems, you can see that we selected this ETRS 1989 Portugal TM06 projected coordinate reference system. Now that's the coordinate reference system of our data frame. However, the coordinates that we imported, if you go to properties and go to source and check the spatial reference, you can see that that's in WGS 1984 UTM zone 29 north. So even though our data frame or the map canvas and the data that's on top of it are in completely two different coordinate reference systems, GIS software like ArcGIS or QGIS have this thing called on-the-fly projection transformation. So what it does is it's basically bringing everything into a common coordinate reference system, which typically happens to be the coordinate reference system of the data frame, just for visualization purposes. So these UTM coordinates, even though originally the coordinate reference system that it belongs to is UTM, just for viewing purposes, it automatically gets transformed into the coordinate reference system of our data frame, which is ETRS 89 Portugal TM6. Let's say now you want to maybe create an export of this dataset, but when you're doing that, you would like to have your coordinates be in the same coordinate reference system of your data frame, which is ETRS 89 Portugal TM6. What you can do is you can right click and go to data and export features, and well, the input features are correct and output features, what we can do is we can maybe go ahead and select the appropriate export location, and I'm going to name this as stations, but the coordinate reference system is ETRS 89 and Portugal TM06. Hope the file name won't be too long. And after that you can click save, and you can see that automatically detected that it's going to get saved as a shapefile. And the important thing is that if you go to environments, from here you can select the output coordinate system, select the coordinates of your current map, which happens to be this ETRS 1989 Portugal TM6, and after that you can just go ahead and click OK. And now you can see that a new layer got created, and I think for the time being I'm just going to deactivate this, or maybe let's just go ahead and remove that completely. And if you now go to the properties of that layer, and if you go to source and check the spatial reference, and now you can see that it's actually in the same coordinate reference system as our data frame, which is ETRS 1989 Portugal TM6. However, if you go to the attribute table these values are actually the same values that we had previously, which we inherited from the original data table, which was in UTM. So if you would like to change these values to reflect the actual coordinate values, which are in this ETRS 89 Portugal TM6 coordinate reference system, what you can do is you can right click over here and go to calculate geometry. And from here under X, you can calculate or recalculate the point X coordinate. And when you click OK, you will see that all of these numbers actually got updated, because now these numbers are in ETRS 89 Portugal TM6 coordinate reference system, and previously they were in UTM coordinate reference system. Well, to be specific, UTM zone 29 north. And you could do the same for Y values as well. Go to calculate geometry and point Y coordinate and click OK. And you can see that now the numbers look completely different, even though spatially they're actually at the same exact precise location around Lisbon. So you can see how the numbers, the numerical values of each of these different coordinate reference system completely differ from each other, even though geographically they're referring to the same exact location. So just as a quick verification, what you could do is, if you go ahead and open up meters from here as the unit of measurement, and let's just say by clicking this point, you can see that we are referring to this point right around here. So if I put my mouse point over here, you can see that the numbers that I'm seeing at the bottom of the map screen, which is around 105,867, is quite close to the value that I'm seeing over here on the table, which is 105,809. And as the Y value, what I'm seeing is 99,272, 99,278, which is just a few meters off. But definitely what I'm seeing based on the position of my mouse point is the accurate XY coordinates of this point is actually the one that we just calculated using the calculate geometry function, and what you're seeing on the table is the final correct set of values. So I guess as you can see, we covered a lot of ground. We just mixed things up quite a bit. So I hope nothing was confusing for you guys. I try to make it as simple as possible. The explanations, if anything is unclear, you can just add a comment down below and let me know. And I'd be happy to break it down to you guys if you need any more additional explanations. But other than that, I hope the steps and the process that we followed today was clear for you guys. I have included the dataset down in the description below for you guys to download and practice and see whether you can actually, get the entire experience for yourself. Thanks a lot, and I'll see you guys again with another tutorial soon.